So my name is Ângela. I will present you some highlights from today, some current situation from today. So this is the first spring weather briefing, but for some parts of Europe, the winter weather has made a comeback with cold, snow, wind, and some heavy rain, convection, well, you name it. And I will show you now the present situation, what is happening today. So this is at 6 UTC, upper levels, and you can see there is a blocking high over the Atlantic, and the polar jet stream is heading north, and it further east, it turns southwards in this deep upper level trough towards the Mediterranean, where a cutoff low is developing. So this weather pattern, almost like an omega pattern, this weather pattern started last Monday. We had cold air advection affecting British Isles that spread to Western and Central Europe on Wednesday, and a storm which was named by the Italian Meteorological Service, the Storm Deborah, dipped in the northern part of Italy. And well, Iberia has been fortunate as it remains under this influence of the blocking high over the Atlantic. And yesterday, several locations in the south of Portugal had 25 degrees of maximum temperature, and or even a little higher. So we are in an area of warm weather. Another trough cutoff low near Morocco. This is another trough, and this is the remnants of the storm Therese that affected the southeastern Atlantic and was named on the 16th of March by the Portuguese Met Service. Further south, you can see here in the image, further south, the subtropical jet is strong, and some severe and rainy weather is taking place in the east. So on the bottom right hand corner. So this is the weather situation. Some frontal system in the over the Atlantic is reaching British Isles. We'll see better in the next slides. This RGB, it's very good to show this difference in the air masses. So the cold air mass can easily be detected with this air mass RGB. The purple and blue colors representing the cold air, so cold air mass, polar air mass, characterized by a low tropopause, can be seen associated with the deep trough and storm Deborah over central Mediterranean. On the other hand, over the Atlantic, tropical air mass, of course, this with higher tropopause, prevails across the Atlantic, and hence the green color. So these two colors, you know already, green colors, tropical air mass, bluish purple colors is the polar air mass. So this cold advection towards the south, we have here the difference very well depicted with this RGB. Also with this RGB, we can see some large area of convection cells over the Atlantic, northern part near Iceland. They are behind the cold front, and this cold front is crossing the British Isles. We can see some high level clouds, the whitish clouds, associated also with the jet stream. And this cold front is moving eastwards. It will affect Central Europe during the weekend. with more cold air advection and more rain and snow. So a new cutoff low will develop west of Deborah storm. Over Morocco, the trough I mentioned before, it's possible to see some deep convection, so some white cloudiness and some deep convection associated, and this will continue but will shift eastwards and will affect almost all parts of the northern Africa. This area is also an area to watch closely. A new, we can see also a new deep low pressure system over Newfoundland, very white, so lots of cloudiness there, will move northeastward towards Iceland. So Iceland will continue to have strong winds and ice seas, for example, and of course some rain. Further east, we can almost not see in this image. There is the convection associated with another low level system, and the severe weather is still happening there. So again, another area to monitor. You can see with the mean sea level pressure, several areas where the isobars are very close together. And of course, these areas have strong winds. Over sea, this can be a problem for marine activities. And you can see some examples, of course, over Mediterranean, North Atlantic, so south of Iceland, small areas northwest of Iberia and Gibraltar Strait. So you can have information from scatterometer winds and to monitor the overseas these high winds. I will show you some examples later. These RGB, so these are the night macrophysics RGB and natural color RGB. These one are from the Severe instrument, can provide additional information about what is happening near the surface. On the western part, so over the Atlantic, under the influence of the high pressure, there are some stratocumulus sheets, so typical water clouds and low-level clouds, and these are pinkish, so with large droplets, so with darker pink, which are larger droplets. If you can see some near north of east of Madeira and north of Canary Islands, you can see some pale greenish cloudiness. So these are also some stratocumulus sheets, water clouds, but with smaller droplets. Further north, we can see some deep convection with the convective cells, with some open cells and closed cells behind the cold front, and they are red. So this means we have here some thick cloudiness. In the eastern part, now with the natural color RGB, there are several areas with ice clouds. We can see with the cyan color. Also, if you look close, you can see some snow on the ground, which is ice particles, of course. So it is also cyan. But also, we can see some areas of low-level water clouds, which are whitish. And in some areas over Finland and in Poland, near the frontal cloud band, we can maybe there is also some fog. So this is a close look over the low pressure system over the Atlantic today at 6 UTC. And the observations, you can see some heavy rain, you can see some snow, and of course at 6 UTC, the temperatures are indeed very low. Lots of convection. This lightning data is from lightning maps. You can have this data in ePort, and lightning data is for the past 6 hours, showing mainly convection and ongoing convection for several hours on the south quadrant of this low. Another product that you can use to monitor severe convection, in this case, heavy rain, is this one from Nowcasting South, the convective rainfall rate. And here you can see two different areas. So the low pressure system over the Mediterranean, with lots of heavy rainfall around the low pressure system, and of course further north associated to the frontal system, and also the other system I mentioned before, which is further east. In this case, we can see it very well with this Nowcasting South convective rainfall rate. So severe weather also happening in this region. So the low pressure system over Mediterranean, which was named Deborah by the Italian Meteorological Service, developed on 25th of March. So this is the temperature at 850 hectopascal and the mean sea level pressure at 0 UTC on the 25th. You can see some cold front crossed British Isles and moved further south. And deep trough, you saw it in the first slide, at high levels emerged over continental Europe. The cold air from polar regions escape into the mid-latitude regions. The blocking high over the Atlantic prevents the warm air from the Atlantic from reaching the continent. This pattern can establish a prolonged period of cold weather in Central Europe. As you can see, this will continue. So this is 24 hours later, same temperature at 850 and mean sea level pressure. And again from ECMWF model at 0 UTC on the 26th, so yesterday. And the polar air mass was almost over the Mediterranean basin. Okay, let's see if we see, you can check if this is normal, and I'm showing here the ensemble control 24 mean temperature minus the model climate. So this is 2 meters temperature anomaly from ECMWF, and this is a forecast for today at 0 UTC. And you can see there is a blue area, so a negative anomaly in the Central Europe, and regarding the temperature. So it's really very deep cold advection over continental Europe. And finally, the same 850 hectopascal temperature for today at 6 UTC from the recent, most recent ECMWF run. And you can see the cold here reaching almost Northern Africa. So this weather situation also brought, as I told you before, some strong winds. And here are some examples of the areas that we can see over the sea, some strong winds over the sea, and some areas with the spectrometer data that can help monitor the areas and keep watch mainly because of marine activities. So on the left, yesterday around 10:30 UTC, ASCAT B winds over North Sea depicted northwest winds with 7 Beaufort scale. So this northwesterly wind started almost on Monday, Tuesday. So they have this area was under these strong winds for several days. So after the cold front crossed this area. So this we can see some 7 Beaufort scale, but there were some moments that was a little bit higher. On the image on the right, you have the OceanSat 3 data from the, so this is an Indian satellite at 11:30 UTC, and this data depicted Deborah over Adriatic Sea. And you can see near Sardinia, some winds with 8 or 9 Beaufort scale, so 40 knots, very, very strong winds. Another example, this is from some hours later, some more or less 12 hours later, yesterday. And we have some strong Mistral winds, so Mistral south of France. We still have strong winds in this area, 8, 9 Beaufort scale, and again, Deborah over the Adriatic Sea. So it's scatterometer data can help us to monitor winds over the ocean. And for this case, there was lots of days since at least since Monday that we have this weather pattern with strong winds started on the northern part of the Europe and now spreading to the south. So this is the weather situation. This weather situation will persist for some days, at least until the weekend. Deborah will stay in the Mediterranean basin with a slow movement eastward. These are the warnings for today. So mainly winds, snow, rain, and coastal events are the main threat. These are red warnings still from yesterday. There were already red warnings for snow and wind for Croatia and Slovenia, and it will continue today. So stay safe. And this was the part of presentation of the current weather situation for today. Thank you for listening. Now, Bruno, the floor is yours.
So I will show the storms that were named by the Southwestern Group during March. So except for Deborah that Ângela already mentioned, and some of their impacts, characteristics and special. I'm sorry, Deborah was not from the Southwestern Group. I will show also some impacts, characteristics, special features of these storms with satellite images, scatterometer data, that are essential tools used in the process of detecting and monitoring these storms over the Atlantic and the Mediterranean Sea, which is the main focus sea areas for this Southwestern group. So, and this season has been the busiest from this Southwestern group since it was started in 2017, 2018 with Portugal, Spain, and France, and then later joined by Belgium and Luxembourg, and this year also by Andorra. So Regina was the first named storm of March. The name was attributed to a low centered southwest of the Iberian Peninsula by the operational center of IPMA in the 1st of March due to forecast of strong winds wind gusts over the Madeira Islands. And here you have the true color RGB from Meteosat 12 or MTG superimposed by the mean sea level pressure and the 500 hectopascal. Besides the strong winds, this storm also generated heavy rain, hail, high waves, and dust transport. Here on the left, we can see the dust aerosol optical depth from product from Copernicus with high values of dust over Morocco and Algeria, advecting mainly over the south of Spain on the 2nd of March. We can also look at two RGBs on the 3rd of March, the HRV clouds from MSG on top and the true color from MTG on the bottom. So this is during the day, and in both of them, it's visible the dust cloud over the ocean, especially with higher contrast here due to higher reflectivity of dust particles compared to the sea surface, and over land. Also, it can also be seen, but with a lower contrast due to lower difference between land and dust reflectivity. Aerosols are very well seen in the true color RGB. This new one, as the scattering effect is stronger at these shorter wavelengths that compose this new RGB from MTG. In some regions, the suspended dust would eventually reach the surface, mainly with wet deposition. On the 4th of March, with the dust RGB, we can see the dust, especially in magenta colors, here mainly over part of the Iberian Peninsula. The blue band contribution is high for warm and low clouds like dust, and the red band contribution is also high because long wave radiation from Earth's surface is stronger absorbed by the dust layer at 10.5 micrometers than at 12.3, which are the channels that compose the red brightness temperature difference. And so it increases the contribution of this red band. Also, because the brightness temperature difference in the green band is rather small for aerosols like dust, this results in a low contribution of this band, and along with the higher contributions of red and blue bands results in this magenta color characteristic for dust. On the next days, the dust advanced to the north, reaching the northern part of Europe, as we can clearly see on the true color RGB and the dust RGBs during the day on the 6th of March, and it affected most of the Western Europe. During the night, the visible channels are unusable, of course, but we can continue to use the dust RGB, and here you can see the difference in color between the North Sea and the Baltic Sea. The North Sea is covered with dust in suspension, and the Baltic Sea has much less suspended dust. And the main RGB difference between both is on the red brightness temperature. So the long wave radiation is stronger absorbed at the 10.5 by dust, and thus contributing to this difference. Looking for the next storm. So Samuel was a low named by the Weather Service of Andorra on the 15th of March due to the observation and forecast of strong winds, mainly affecting the Gulf of Lyon in the Mediterranean and the Pyrenees. Curiously, as I've already mentioned, Andorra joined the Southwestern Group this year, and this was their first named storm. This geocolor image is basically a combination of the true color RGB for the daytime part on the Earth, so here on the right, and the NASA black marble static image superimposed with the 10.5 and the brightness temperature with the 3.8 for the nighttime of the Earth. So here on the left, and on the left you can identify ice and liquid water clouds shown in whitish and bluish colors respectively. Samuel low deepened near the Gulf of Genova, and the interaction with the ridge that extended from the eye over the Atlantic to the north of France, so generated the strong wind Mistral over this part of the Mediterranean. We could detect wind. We could detect wind so over water, as Ângela already showed a very nice case for Deborah. In this case, with the data retrieved also by OceanSat-3 satellite with the scatterometer sensor OSCAT-3. The data shows a northerly flow over the Gulf of Lyon on the western part of the low, and the scatterometer retrieved winds of around 40 knots, so gale, 2 strong gale force winds, very dangerous over water. After Samuel came the Therese storm. Here, at the first instances of Therese, you can still see the Samuel low over the Mediterranean near Libya. Therese was a low-named storm by the Azores Operational Center of IPMA at the 16th of March for high-impact weather over Portugal, especially over the Azores Islands, with an initial orange warning wind. Therese was surely one of the most slow and enduring storms that has been named by the Southwestern Group, roughly influencing the state of the weather for about 8 days from the 17th to the 25th of March in Portugal, Spain, and mainly on the Atlantic archipelagos of these countries. In the early part of its life cycle, it would influence Azores archipelago with a decrease in temperature due to the cold air advection from the north, with the issuing of temperature warnings for these islands, and snow reaching low altitudes in some of the Azores Islands, which is not a usual event. The low continued slowly moving south and would affect Madeira Islands, namely with wind and rain. Also, an unusual tornado hitting the small Porto Santo Island, a phenomena never registered in that island. And on the later part of the cycle, the low would affect primarily the Canary Islands, causing also a red warning issuing, and it would end its cycle filling up over the coast of Africa. This is data from the altimeter Altica on board of Saral satellite from the Indian Met Service and CNES, and the comparison with the SEMWF wave model. And this kind of observations allows for the forecasters to understand if the observation and forecast are similar or far apart in some regions of the Atlantic or over the sea. The image on the left shows the forecast by the SEMWF wave model superimposed with the altimeter data, and the difference between the two. So blue values indicate altimeter observation higher than the forecast, and red values indicates the opposite. So this is very helpful for if you use the data from several altimeters to get the sense of behavior of the model and the performance under that situation. On the right side, we also have a graphic with both values over the swath pass of the altimeter and the comparison between them. Here we have the data from scatterometer ASCAT-B on board of METOP-B. The image on the left shows the scatterometer winds in flags colored according to the Beaufort scale, and you can easily see the low Therese. On the right, we have the wind speed bias plot, so showing the difference also between the wind speed measured by the scatterometer and the one forecasted by the SEMWF model. So here red colors indicate that scatterometer wind value is higher than the value forecasted by the SEMWF. This is also extremely useful, primarily for marine forecast, and in this case also to understand the model was underestimating the wind on the eastern part of the low as it approached the Madeira Islands. So the strong air advection, strong air cold advection over the Azores Island we saw before, associated to the low Therese, and the right atmospheric conditions generated the gravity waves with the characteristic cloud pattern we can observe in this true color RGB image. So these are named Lee waves. They can present serious threat to all kinds of aircrafts. Here the waves in the atmosphere were visible through satellite images, which is not always the case. On the left, we can see the orography of the Azores Islands, which has the highest peak of Portugal in Pico Island, with 2,351 meters, and here marked with a star. So for better reference with the next images. Looking to this pattern through other RGBs, we can see that in the cloud face RGB you can distinguish between thick water clouds with large droplets on the windward side, so on top of the image, and thick water clouds with small droplets on the leeward side, so more to the bottom of the image, with the difference being in the contribution of the green and blue bands. In the cloud type RGB, we can see a pattern of gravity waves formed by thin cirrus clouds that barely were visible or that were not visible in the other RGBs. Here, the difference between these two types of clouds that are signaled is marked on all three bands very clearly. You can also see the water vapor channels, in this case the 6.3, and they are particularly interesting for us to see the wave pattern, especially in cases when the air is very dry and there is no cloud formation, which is, and it's not possible to observe it through visible and near infrared channels. Of course, this was not the case presented here, but if we have like a pattern, we can see the pattern if there is no clouds using these water vapor channels. Finally, if you look again at the true color RGB and observe the differences between the 18 UTC and the 19 UTC images, we can see the difference in height between the lee waves and the low stratiform clouds, because with the low angle of the sun at 19 UTC, we can see the shadows of the lee clouds over the low clouds on the right image here. So I hope you enjoyed it. Thank you.